Hello all, I welcome you on behalf of Edureka for mastering Git and GitHub course. In the last module, we worked on branching and merging. We also learned different ways of merging the branches and performed basic Git operation on branches like create, checkout, delete, and so on. We also created tags and understood the difference between branches and tags. In this module, you will look at different workflows that are possible in the Git. You will also see different kinds of workflows that can be created to suit your development need. And in the end, we are going to use Git in real-time open source projects. So what is a Git workflow? A Git workflow is a recommendation for how to use Git to accomplish work in a consistent and productive manner. Git workflows encourage users to leverage Git effectively and consistently and offers a lot of flexibility in how users manage changes. There are many features in Git to assist any type of workflow. The best workflow is the one on which whole team agrees. Workflows can be created according to your or your company's requirements. Since each user has its own local copy which isolates the work from other team members, thus reducing the errors that are going to go into production. Workflows are guidelines rather than concrete rules and can be suited according to your needs. Now, what are the advantages of workflow? Number one, development process becomes more organized. Any number of developers can work on the same file at any time and without having additional time to spend on the merging and other strategies. Easy to find mistakes if any developer makes. Reverting the code is easy, facilitates effective code reviews, and all team members follows the same strategy. So there are different types of workflows, but we have to remember that these are all just guidelines rather than some concrete set of rules. So there are four popular workflows: the centralized one, feature branching, Git Flow, and forking. Let's look at the centralized workflow. So this is recommended for people who migrate from SVN, CVS, traditional VCS. So if you remember, SVN is the type of centralized version control system, while Git is a distributed one. So in the centralized workflow, the central repository serves as a single point of entry for any change in the project. So in this, master is considered as default branch and all changes are committed to the master branch, which is this one in this diagram. And all these are developers, individual developers. It does not require any other branch, which makes the transition very easy from SVN. Developers can also use Git's feature if they like. For example, the commits in local repository, which is mandatory, I guess, and the branching and merging. But since this workflow requires only single branch, then branching and merging is out of picture. But once they get comfortable, they can then go ahead and move to some other workflow. So in this, as we said, a central repository is created. And if the current repository is in other VCS, the code can be migrated to Git repository. We already saw that we have how to initialize an existing project and convert it into a Git repository. The central Git repository can be created on GitHub or using Bitbucket. So this is another remote repository available to us, which allows the private repositories, while GitHub has only paid private repository and it only allows free public repositories. So developer creates a local copy of the central repository. Since this is distributed, each one has local copy along with all the metadata, and they can change the code and commit locally. Once the changes are in local repository, they need to be pushed to the central repository so that others can pull them down and then continue the work. If multiple developers are working on the same piece of code, then pushing to master may raise conflicts which needs to be resolved manually. So we already saw this, that how to resolve the merge conflicts. There are different tools to identify, and in many cases Git will also automatically identify the or resolve the conflicts until and unless they are on the same file in the same line. Now, managing conflicts in the centralized workflow. So when master is ahead of the local branch, in that case conflict may occur. So for example, this is the remote master and this is the local master. Now my local master is ahead of the origin master is ahead of the local branch. In this case, the conflicts may occur because pushing local changes to master would override the official commits. Now to avoid conflicts, what we can do is we can fetch the master branch and then we can do the def. Once that is done, we merge the changes locally, and once we have merged it locally and manually, we push it to the remote. Now resolving conflicts is already covered in the previous module, we saw different strategies. We also saw the rebase, which is different from the merging, wherein we take a patch and then apply it line by. And how does Git apply it? Git applies the patch line by line. The next workflow is feature branch workflow. Now in this, all new feature development is done in the feature branch and not in master branch. So master branch remain as it is, which is for the production line code, while new features are developed in the feature branch. So it allows developers to work on their own branches without disturbing the master branch. Master branch is away from any broken code or unwanted conflicts, because once it is tested, then the branches are merged onto the master. While other workflows are focused on repository, this workflow emphasizes on the use of branching for better development. They can be any number of features, and these branches will be merged into the master branch. Now, working with the feature branch workflow, this workflow considers master as the official project. By official project, we mean the deployable or the production quality code. In this, rather than committing on the master, we create a new branch for each feature, and then once it is finished, we merge it with the master branch. Now, for this to be more effective, features branch should have a meaningful names rather than having any random name. So once feature development is done, it is merged to the master branch, like in this case. And the branches can be shared with other contributors in the team to help develop more features and to avoid changing the master branch, because master branch is the production quality code that we are maintaining, or the at any point of time the master branch, any commit in master branch should be deployable. The next is the Git Flow workflow. Now, to use this workflow has been introduced by Vincent Rinson, which helped simplify the development and the release management. So it is used in daily development activity. Now, Git Flow is a branching strategy or the model recommendation to use Git effectively. It provides a robust framework to manage large projects, more suitable for team having scheduled releases. For example, in your company, you might have a releases schedule as 1.0, 2.0, or so on. So this is more suitable for those releases where it is scheduled. It comes with a Git plugin to facilitate the command line, because in this we have the benefit of this Git plugin, through which we can reduce the number of keystrokes, and most of the Git operations can be achieved using the Git flow. In this example, for example, we have different branches. We have the master branch, which is the main, then we have the release branch, then we have the feature branch, develop branch, and the hotfix branch. All releases are going to the release branch. Now there are different advantages of using Git flow workflow. Now there are different advantages of using Git flow workflow. Number one is this is very useful in managing larger projects. As we already said, that if they are scheduled releases, then this is, especially in the agile environment, then this is very useful. The collaboration will be increased among the team members, since there are different branches and such as release and the hotflex or the development. So the collaborations will increase. The chances of wrong branch check-in and merge is reduced. This is user friendly because we have a Git plugin. Hence, it is more user friendly for us, because many complex operations are hidden and an abstraction layer is provided in this plugin. It provides effective branching strategy. For example, separate branches for preparing, maintaining, and recording releases. It illustrates a strict branching model for project release. Now, how the Git Flow workflow works. So there are two branches to maintain history: the master and the develop. Master is maintains the actual release milestone along with proper tags, and develop is for integration branch for features where developer will merge their work. Now this is similar to the feature workflow wherein we had the feature, but here we have the develop branch. Now this workflow also assigns roles to specific different branches and defines how they should interact. For example, the release branch. A release branch is forked once development branch contains enough features to be released. For example, it is forked at this point of time. Once we have 4 features available, then a release branch will be released. Hotfix, which is this. Now this branch is created when an immediate fix is required. Something is broken. And to do that, this is directly from the master branch, because immediate fix is required on the production quality code, or the code which is in the production environment. Next is the feature branch. If any new feature have independent line of development, not if, but new feature have independent line of development, so they are branched off from the development branch. So we have release branch, master branch, which contains our code, release branch, which is forked when we have forked from the develop branch, and we have develop branch, which is going on continuously. Hotfix branch is for fork directly in most cases from the master branch, and we have feature branch, which comes from the developer branch. Now, unlike other workflows, this keeps two branches to record all changes in the history, the master and the develop. Master branch stores all release history, while the development branch is nothing but integration of various feature branches, and all the development work happens here. Now, each new feature should be started in the feature branch. As we said, this is a guideline and not a strict rules. So, guideline says that each new feature should be started in a feature branch. Once the feature development is finished, it should be merged into development and the feature branch should be deleted. Before merging to develop branch, it is developer's responsibility to get it tested by QA tester. So multiple features we can have one more feature branch as well going on in parallel, and it has to be tested by the QA tester before being merged to a development branch. This will make sure that the development code is always working. Now feature branch never interact with master in this workflow. Rather, if we require a release, then release branch will be forked from the develop branch and then merged to the master. So Git Flow is a plugin, as I said, in the Git, and this can be installed pretty easily. For example, if you're on Mac, then you can do git brew install Git Flow. I use this command to install the Git Flow plugin. Now, once I have the plugin, I can start the branch. So I can use this branch. For example, I'm starting Git Flow release, not finish. I'm using Git Flow release start R1.1, let's say. First of all, it has to be initialized at Git Flow, right? If I go to this temp, then this is a Git Flow command. Let's come out. Let me remove the temp. Let me restart it. So now let's do Git Flow init. This will create the two branches for me. What it is asking is that once I do the Git Flow init, it asks for branch name for production releases. I prefer master. For next releases, development, develop. Any supporting prefixes for feature branches. Feature is good enough for me. For release branches, for hotfix, for support branches, and finally version tag prefix. So I'll say V. Now if I look at the branch, then I have two branches, develop and master, and I am on development branch. So once I'm done with the feature, then I can do, let's first of all start the feature branch. And how do we start it? We say feature start feature branch. So we say get flow feature start feature branches. Let's say we are adding the loading bar. So what it says is that it switched to a new branch immediately. Feature spinner. The summary of actions: a new branch feature spinner was created based on the develop. You now want branch feature spinner. Now start committing on your feature. When done, use get flow feature finish spinner. So I'm gonna initiate this spinner text, and I'm gonna say this spinner rocks. I'm gonna add it. I'm gonna commit it. Now once that is done, I can finish the branch. So how do we do it? I take the same old command, and instead of start I say finish. So once I finish, many things happen. Number one, it switched to branch develop and merged the feature branch containing the file spinner.txt, and it deleted the branch feature spinner. Now summary of actions was that the feature branch was merged into develop, feature branch has been removed, and you're now on branch develop. So if I do now branch, the feature branch should not be existing. And if I look at the file code, then I have spinner.txt. If I look at the log, then I have the log that added a spinner. Now release branch workflow. Once I have enough features, then release branch will come into picture. So it represents a new production release. The code from this branch can be deployed on test production servers, because we already said the feature branch should be tested from the QA before it is merged into the develop branch. That is why release branch can be deployed on the production server. In case of issues in release branch, they are fixed in the same release branch, and then changes can be merged back to develop. No new feature addition is allowed in the release branch, and this should be followed strictly in the Git Flow workflow. Now once ready, the release branch is merged back into the master branch. So this is the release branch workflow. It creates a release branch with proper version number on the release master. Once the release branch is tested and available for production, following steps are performed. The release branch is merged into the master. Tag is created for feature reference. The merge changes back to develop branch and the release branch is deleted. So let's look at the workflow using the command line interface. So let's start a release with the release name. So I'm going to say Git Flow release instead of feature. I say release start spinner. This is not a very release number. I should have used 1.0 here. So let's, since I've named this spinner, because this is how it will be in your organization, not spinner, but it will be 1.0, 1.2, 1.1.1 with many features into it. We now have only one features, which is the spinner. So once I did this, many things happened. A new branch release spinner was created and we are now on branch release spinner. Follow-up actions are we bump the version number now, start committing relative fixes, and when done, we run get flow release finish spinner. Now, if I look at the status, then nothing. If I look at the branch, then I want release spinner. Now let's open the spinner.txt and say this is spinner not rocks, but this is spinner now spins. I'm gonna move this to the staging area and then commit it. Now I fixed the bug. Once that is done, I go back to this branch and I finish this. Now this happened because they asked for comment. I have to write the message for the tag. Let's say release r1.0. Now a lot of things happen and all these files open in the Vim editor. They ask for my comments into it. Now number one, the latest objects have been fetched. Release branch has been merged into master. Release branch was tagged as vspinner and the release branch has been back merged into develop and the release branch has been deleted. Now if I looked at the get status now, then I'm on branch develop, and if I look at the branch, then the release branch should not exist, right? If I look at the spin, then this spinner now spins. If I go to master, then let's see if the file exists. Yes. If I go to spinner.txt, then this is fine. Now let's go to develop again. So many changes happen and we didn't did anything much. Our life became much easier with this Git Flow plugin. Now let's look at the hotfix branch workflow. When it goes into production, for example, let's say we figure out that the spinner is not spinning fast enough and we have to fix it. So hotfix branch is generally created from the master branch since we are fixing the code in the production, and the bug fix in the release are actually fixed in the release branch itself. So bug fixes are carried out in the hotfix branch. Once fix is tested and completed, we perform below steps. Not we, but the plugin will actually perform the below steps. It will merge the hotfix branch to master. Number one, it will create a tag for clean history and reference. It will merge changes to develop branch and it will delete the hotfix branch. Let's look at the current tags. So there's tag vspinner because we moved that to the release spinner. We actually released a feature so with the name spinner, so that is vr1.0. Ideally, if a release name should have been 1.0, 1.1, 1.2, something like this. So the version number would, or the tag would have been v1.0 because we gave the prefix v when we were setting up the Git Flow. So let's look at the Git Flow. What we're trying to do in this, we will introduce a new develop branch and we are going to push that to the origin. Any change. So any developer from team can create an empty develop branch and push it to server. Now develop will have complete history and master will be used as reference. So other developers can now clone center repository and start working on develop branch. Next we check out this is what we are doing is we are cloning the remote. Next we check out the remote branch. To initialize the Git Flow and facilitate branch selection, we do Git Flow init, which we already did, and it asked for all these features for us. Then what we did is we changed the files and then we committed them, and in the end we started with the finish the feature. But before that we also started the feature because we are finishing this feature, new feature. In the next line, this should have been before. So initially we started new feature and in the end we finished the new feature. After we made the changes, we finished the new feature, and the summary of actions is right. This is what we're doing here. So you see that Git Flow has made our life such simpler, and it is managing with this plugin in hand. It is managing everything on their own. Otherwise it would have been a very complex process both to use and would have been like really very impractical. But this has solved a lot of problem for us because we now have a great workflow with us. Next one is the forking workflow. Forking workflow, a server-side repository is maintained by a project lead. We have a project lead who maintains this repository. This is very often and suitably used for the public open source project, especially in GitHub. So we have different open source projects, for example, the Spark, Apache Spark, or Django, or any such other projects. So their code says freely available. And if anyone wants to go ahead and make changes in it, then they use the forking workflow. They have to follow the forking workflow. So what happens in that? There is a single server-side repository which acts as a central code base, which is here. And every developer maintains two repositories, a public server-side repository, which is this, and a private local repository. We have three developers here and they have three private repositories. Now changes are merged without the need for everyone to push to the central repository. You can go ahead and push to your local repository, or to your, not the local, but to your own private server-side repository. Now only the actual owner have the rights to push to official main repository, which is this one. In this way, owner accept the commits, and at the same time there is no need to provide write access to every contributor. So there is one lead who is managing how the changes will go from their repositories to the main repository. Anyone can fork this repository and create their own, and then they work with it, and then they ask, and then they submit their changes to the lead, and lead will then review and then push it to the main. Now this is how the forking workflow works. So there is a main repository. For example, let's say there is Apache Spark repository. Now that in the first step we fork it from the central repository to personal remote repository. We go to GitHub. Let's say we go to GitHub, and then we already forked a lot of repositories here. So let's go to this Apache Spark. So for example, we go to Apache Spark and then we click on the fork button, and we'll have a repository available to us here like this. So this is the forked repository available to us, Edureka GitHub Spark. We cloned from remote to local repository. For example, we also have another repository, since Spark is a pretty heavy repository. So we forked this new life scrapper from IUCDU, and we click on the fork, and once we did fork, we have this repository available to us. So next is what we're going to do is we're going to clone or download it. So we're going to clone it like any other repository. I will go ahead and I'm going to remove this existing one, and I'm going to do git clone. Now if I cd into the new life, and if I do git remote -v, then if you see that this is my repository, right, Edureka GitHub, and not the original owner's repository. So once I have cloned this repository to local, I make changes on top of local, and then I push those changes to my private repository, which is the forked one, available on my GitHub, Edureka GitHub, the Needle Scrapper. Now once that is done, then I go ahead and generate pull request to merge the code onto the central repository. So I go there and I say, okay, let's start with a pull request. I already have another one where we have one pull request here. So what will happen is that, let's follow the new scrapper again. I go to new scrapper and I create a new pull request. If you remember, we created the pull request back in the previous module. So if you're not sure what we do here, I suggest you to go back and understand what we did. So we have this base, which is master, which is the original owner, and then we have the fork. So we check the master and the branch, but they can be automatically merged because there are no changes between them. Now there is one change, which is this is test line. This is available in the GitHub. We view the pull request, and we already have one pull request, sorry, here, right? We create the pull request, and then the lead or the owner of the original repository will review it and then add it to the repository if available. So official public repository for open source project is created by owner and hosted on the server. The third parties, such as the Edureka GitHub in this case, or me in this case, who wants to contribute, cannot directly clone the repository. I cannot clone it, but I can fork it. So once I fork the repository, it will result in creation of my own public repository, and every other contributor can pull from others repository but can't push to those repository. There is always pull but no push to others repository. They can always push to your own repository, right? So contributors now clones their own public repository and start working on it. This is same as their private development environment. Now steps to push the changes to the project. The commit is made on top of the local repository, and we generate the pull request with the main repository, which will notify the project owner. Once the project owner reviews and manages the changes, they are merged to the main public repository. This is how it is used in the open source project which are available especially on the GitHub. Anybody can go ahead and fork the repository and start working on that project. Developers have the flexibility to work on their changes locally, and once everything works fine, the changes can be merged to public repository after the permission and the of the project lead. So they are not merged directly, but they are submitted for the review to the project lead or the repository owner. So this is the main repository. You fork it, you have your personal repository and the local repository, which is your workspace. Now, public repository access and check-ins cannot be done at random, which may result in various conflicts. So check-ins to the main server are controlled, but you can have the local changes downloaded to your repository using the pull, right? And there's the project lead. You cannot check in directly. You check in through the project lead who approves and then allows it, approves or disapproves. So workflows addresses all these concerns and is best fit for real-time open source projects. If you go back and look at the Spark, Apache Spark, then the contributors are, but if you go to the Apache Spark, then there are a lot of contributors there, right? Look at the fork, it's 17,000. There are 1,310 contributors, right? There, and the commits are this much. There are different branches, different releases, so on. So this is very useful in these scenarios. Now let's look at the working workflow using CLI. We fork the official main repository on server to your account. We already did that in the previous, but in this we can go directly and click on fork. From GitHub UI, we click on fork button. Let's go ahead and let's do it. Let's find some other project. So I again will go to this one. Let's go and find some other repository, which is, okay, let's go to Spark Vagrant. This is just a readme available. So what I'm going to do is I'm going to fork it. So this is forking the I should use Spark Vagrant into my personal repository. Now this is available in my personal repository. Next, what I'll do is I'll clone the repository to my local. To clone it, I'll go there and click on clone, download, copy the URL, and I'll say git clone, and let's clone the URL, the repository, the Spark Vagrant. Now if I do the remote v, we have only origin available. This is not a git, so Spark, let me go to Spark Vagrant. We have only origin. Now what I'm going to do is I'm going to add upstream. So I'm going to execute the command git remote add upstream and then the repository name. I'm going to change it with the original owner, which is right. Also I'm going to add upstream to the user's official owner. Let's also try this. Now what I'm going to do is I'm going to check out feature 1. I'm going to create a new branch and switch to it, and I'm going to commit in it. Git status, let's add test, create a new file, blank new file, test.txt, and I'm going to do commit git add dot git. I did it. Next is we push changes to public repository. How do we push it? We go git push origin master. Okay, we are on feature 1, so not master. We're gonna push it feature 1 branch. Authentication failed. Let's try it again. This is done. So if I check this out, let me refresh it, right? So I have a feature 1 branch also available, which has test.txt added. Right now we create a pull request for code review and merge to owner. So how do we go? I go there and I create a pull request. Let's create a new pull request. I'm gonna say branch master for original, and I'm gonna compare with feature 1. Able to merge these branches can be, we create a pull request, and if I see here no commit for this range, so we have just added a file test.txt. I create a pull request, I added a new file test.txt. Let me add this as a comment and new file. Let me add this as a title. Allow edit for maintenance. I uncheck it and I create a pull request. So this pull request is created. User, it says Edureka GitHub wants to merge one commit into IUCDU master from Edureka GitHub feature 1, and is one commit. This branch has no conflict. Now we discussed the various Git flow strategies today. We also looked at the four most popular types of workflows: centralized, feature, the Git flow, and the forking. In the Git flow, we also looked at the Git flow plugin available to us. And in the forking, we saw that how this is used in the public repository, wherein we fork the changes and then we submit it for the approval of the original repository owner or the project lead, and then they go ahead and implement it. I hope you're now much clear with the Git workflows. Thank you.